Hey everyone, welcome to The Explainer. Today, we're actually going to crack open the foundation of programming concepts together and explore the very DNA of computer logic. I mean, if you've ever wondered how a piece of software actually understands the information you give it, whether that's your name, your bank balance, or just a simple click of a button, you are absolutely in the right place. So let's just jump straight into the digital labels that make literally all of modern computing possible: data types.
Okay, let's dive into this. I want you to imagine trying to store your birthday inside a standard pocket calculator. Or think about trying to save a high-res profile picture into a text field meant for a phone number. It doesn't make any sense, right? It's completely absurd. But here is the secret. Computers kind of think in exactly that same way. Before a computer can store any piece of information, it has to know exactly what kind of information it's looking at. It craves structure. It needs to avoid disorganized, chaotic data because otherwise the whole system just breaks down. So, to solve this logic gap, here's our roadmap for today. We are going to start with the labeling problem, break down the common data types, and see them in real-world applications. After that, we'll cover some common beginner mistakes, and then we'll wrap the whole thing up with the logic of operations. All right, part one, the labeling problem. Basically, why computers absolutely need to know what they are looking at. The core issue here is that computers, at their heart, are deeply structured machines. Because they don't have human intuition, they need super explicit instructions about the format of data before they can allocate memory and actually store it. Think about it. If you show a human the number 20 and the word 20 spelled out, we know they mean the exact same thing. But a computer, it absolutely does not. And that brings us to our core definition. A data type is simply a label that tells the computer what kind of data is stored inside a variable. You can think of a variable as a container. Imagine you're moving into a new house. You've got dozens of cardboard boxes. One has books, another has your winter clothes, and another is just full of your fragile glassware. Well, if you don't label those boxes, the movers have no idea how to handle them, right? They might toss the glassware or stick your winter coats in the kitchen pantry. Every single box needs a specific label so you know what's inside and how to handle it safely. In programming, data types are exactly those labels. Moving on to part two, the common data types. We're going to look at the 5 core labels of programming. Now, across almost all programming languages, whether you're looking at Python, Java, C++, whatever, there's a core taxonomy of standard labels used to understand data. Let's logically walk through these 5 foundational building blocks. First up, we have the integer. These are just your standard whole numbers, no decimals. Logically, you'd use integers whenever you need to count something whole, like an age of 18 or a score of 95. Next is the floating point, or what programmers just call a float. These are your decimal numbers. You use floats when precision absolutely matters. Think of a height of 170.5 centimeters or a price of $499.99. Then we have the string. This is just text. Letters, words, full sentences. Anything inside quotation marks, like the name Lloyd, is a string. Fourth is the Boolean. This one is pure logic. It only has 2 possible values, true or false. It's used to answer direct questions, like is logged in equals true. And finally, we have the character, or char, which stores just a single symbol, like the letter A or an @ symbol. Really, these 5 labels make up the alphabet of programming logic. Part 3, real-world applications. Let's see how your favorite apps actually use these data types. Let's ground all this abstract logic in some everyday utility. Think about how a complex social media profile on an app like Facebook breaks down perfectly into these exact logical data chunks. Your name? Well, that's just stored as a string of text. Your age? That's an integer, a whole number. Do you have a verified account with that little blue check mark? The computer doesn't see a badge, it just sees a Boolean, true or false. And a profile rating or algorithm score? That might be a float, like 4.8. It's kind of wild to think about, but all the magic of social media is really just these basic data types stacked on top of each other. We can reinforce this with another everyday example, a food delivery app. The restaurant name is obviously a string. The delivery fee, well, because it involves money and cents, that absolutely must be a float. The items ordered, because you can't really order 2.5 burgers, is an integer. And whether the order is complete is, you guessed it, a Boolean. Every single program you use daily relies on many different data types functioning all at the same time. And honestly, if even one of these labels is wrong, the whole app crashes. Which leads us perfectly into part 4, common beginner mistakes. What happens when labels go completely wrong? So choosing the correct data type is absolutely vital for software reliability and performance. Let's explore exactly what happens to a computer's logic when we make a mistake and apply the wrong label. Check out this hidden logic difference here. We have one version where age equals 20 wrapped in quotation marks, and another where age equals 20 without them. To us humans, they look completely identical, but to a computer? The one with quotes is a string. It's just a collection of text characters, literally no different to the computer than the word apple. The other one is an integer, an actual mathematical value. If you try to do math using that string version, the computer is going to throw a massive error because it literally doesn't know how to mathematically calculate a word. Here's another really dangerous mistake: using an integer for a decimal value. Say you set a price to the integer 199 instead of the float 199.99. The computer just completely chops off the decimal. You lose that 0.99 entirely. Now, in a high school coding project, maybe that's just a tiny bug. But imagine the absolute disaster if an online banking app lost all the cents on every single transaction just because a developer used the wrong data type. When it comes to floats, precision really matters.
And check out this comparison. Using text strings like the words yes or no instead of true Boolean values like true or false. Now, sure, you could technically program a system to read the word yes, but it hugely complicates the programming logic. The computer has to read the string, check the capitalization, and then try to interpret it. Booleans, on the other hand, are native binary logic, just ones and zeros. Using true and false makes making decisions vastly simpler and way faster for the computer to process. All right, our final section, Part 5, the logic of operations. We're looking at how data types dictate what a computer can actually do. You see, these labels do a lot more than just organize data. They actually dictate the strict rules of what a computer is allowed to do with that data. Look at the math comparison here. Integers 25 plus 10 equal 35. Because they're numbers, the computer performs standard arithmetic. But look at the strings. Hello plus world equals hello world. The computer doesn't do math here at all. It performs what's called string concatenation, which is really just a fancy way of saying it sticks the text together end to end. The exact same operation, that plus sign, behaves entirely differently depending on the data type it's handed. To summarize this whole system, try to visualize computer memory as a giant warehouse. Inside this warehouse are millions and millions of storage boxes. For the computer to process information accurately and efficiently, every single box requires two distinct labels. The first label is the variable name, basically what the box is called, like student name or price. The second label is the data type, what kind of item is actually inside, like a string or a float. Without both of those labels, the warehouse just falls into total chaos. But with them, the computer can operate at absolute lightning speed. Which brings us to our ultimate question. Now that our data is perfectly organized, beautifully labeled, and sitting cleanly in the warehouse, how does the program actually start making decisions? I mean, how does it compare a user's password to the stored password, or calculate the final total of a shopping cart? Well, the labels are just the beginning. The actual magic happens through something called operators, and that is exactly what we're going to be diving into next time. Until then, keep analyzing the data around you, and thank you so much for exploring this logic with me today.